right. So one of the five facts about enzymes that I did fail to mention is the fact that they are very fragile and they need to be put in optimal conditions in order to do their job. So temperature is one of those optimal conditions that if you go above or below the threshold, the ability of the enzyme to perform its reactions decreases. So think about our body temperature. What are we? 98 point, I think 7. It has changed by a decimal, but there's a reason why we have an optimal body temperature. When we operate outside of that body temperature, something is wrong with our body. Usually we're sick. Another condition that can affect whether or not an enzyme will work is pH. And so enzymes can be designed to work in specific pH environments. So we have enzymes in our mouth that work in a relatively neutral pH environment. And we have enzymes in our stomach, which are going to be working in an acidic environment. If you take the enzyme in our stomach and put it in our mouth, it won't be able to work because it requires that very optimal, very specific condition. All right. Enzymes also can be regulated in a certain way. And to do that, we can use cofactors. So cofactors can aid in the function of the enzyme, make them work a little bit more better, as I like to say. So, or they may get in the way of the enzyme's ability to work. So cofactors, some cofactors are inorganic. So ions like zinc, iron, or copper. Think about some of those essential elements that we require in very minute amounts, but they may aid in whether or not an enzyme works. And if a cofactor is organic, like vitamins, we would call that a coenzyme. So inhibitors are molecules that can inhibit the enzyme's ability to do its job. That has kind of a negative connotation because sometimes we don't want the enzyme to do its job. So these come in essentially two categories: competitive and non-competitive inhibition. Competitive inhibitors are going to compete with the substrate. So here's the inhibitor, it's competing with this substrate. It's blocking the active site, and therefore it's not enabling the reaction to take place. Non-competitive inhibitors are those that are going to bind someplace other than the active site. So here we have our non-competitive, and here we have it's binding to another location on the enzyme, and it's causing the enzyme to change shape, and no longer can that substrate bind with this, preventing this. So here we can see them side by side, if you will. So this is actually important in inhibition, feedback inhibition. Sometimes the enzyme is required, and then if enough product is produced, we need to stop the enzyme from reacting, and that is known as feedback inhibition. So enzyme 1, enzyme 2, enzyme 3, we get this product. Well, if this product is present, that's going to stop enzyme 1 from reacting. And eventually this product is going to be utilized. We're going to need it again. It's no longer going to be blocked. Enzyme 1 is active, enzyme 2 is active, enzyme 3 is active, then blocked. All right. Some enzyme inhibitors, ibuprofen, which is going to be involved in pain sensation, blood pressure medicines, antidepressants, antibiotics. Proteases are going to affect the virus that causes HIV. So inhibitors, while it sounds bad, can actually be a benefit to controlling systems or controlling states within the cell. Remember that homeostasis is very important. Right? On the other hand, they can also be bad. So a lot of inhibitors found in pesticides or in poisons cause death because the enzyme that is required to sustain life is not working properly.